Sam Chanoski. I work at Idaho National Laboratory, which is one of the 17 national labs funded by the DOE complex. And INL is known as the nuclear laboratory. We have got 3 functioning reactors on site now, 52 over the life cycle, and depending on what day you look at the schedule, plans for anywhere from 6 to about 18 more to be built by the end of the decade. However, I work in national and homeland security, and particularly a lot of my time is spent dealing with grid cybersecurity issues. It's kind of a broad term, but it fits really because it's what I do. I get to be broad, get to get out there and make links and connections between different programs. And with that, what I see is oftentimes there's a lot of similarities more so than there are differences. Now there's different ways to explain it. There's different marketing schemes. There's different names for it oftentimes. But fundamentally, good principles are good principles. And this applies to the design, the engineering, the automation, the protection, and the security of it. So what I wanted to do today is, because I'm not an owner-operator, I'm not a vendor, the national labs do things that the private sector can't, shouldn't, or won't, is I want to talk about mental models and some ways to think about sort of the generalization of all these different things that I've seen across the years in the companies looking at grid cybersecurity, and give you a couple ways just to organize it in your mind. Hopefully you'll find something useful in it, because the thing about mental models is they can be really useful to you as long as they're accurate, and that's important. So this will be a little bit of possibly level setting too, and would welcome questions or challenges, because this is one person's opinion that we've ran past a couple other folks, and I get a lot of head nods, but not much of a yeah, no, you need to change this. So I'm always looking for that challenge as well. So the first one here, let's talk about the grid itself. That kind of nebulous, ill-defined term. I used to really dislike the term, the grid, because it was very imprecise. I've grown more comfortable with it because there's all the technology, the infrastructure, the steel in the ground, but there's also the human element of it. There's also this intermediate level, whatever you want to call it, the monitoring and the control systems, the industrial automation that take the human intent and impose it on the steel on the ground to create that safe, reliable source of electricity for everybody. Now, when you think of the mental model of the grid, many times you'll think back to kind of the traditional diagram that NERC uses, FERC uses, the Department of Energy uses, everybody uses it, and it's linear. It's got generation on one side, then it goes to a transmission station, then to distribution, then over to some houses or factories on the other side for load. And it gives this impression that energy flows in a nice straight line. And while that's not incorrect by the laws of physics, it oversimplifies and it masks some complexity that's actually in the system. And if you look at this here, this kind of crude graphic that I came up with, that's why it's not the sharpest in the world, because I made it on my own PowerPoint slides. But the bulk electric system, that dense interconnected network system, it kind of is like a cloud. It can take a lot of damage to it. It's very redundant. It's resilient. In the case of the electric sector, it's also heavily regulated by NERC and FERC. That has some benefits. That also has some pains that come along with it. But we'll touch on the aspect of compliance very briefly later on in this. But then from that, you've got these series parallel paths coming off of this dense network that can just take a beating and still keep functioning. And it gets a little less resilient here in these series parallel paths that eventually make their way down at the very bottom to the loads, to those individual residences, industrial facilities, government complexes, whatever, that are those end-use customers. And at some point, it gets to a radial connection for the last 100 feet, mile, 100 miles, whatever the case may be. Recently, in the last 15 or so years, you start seeing these DERs, distributed energy resources, which is where you see wind, and you see solar, and you see geothermal, battery energy storage. Pick your technology. I've heard at least a dozen different ones talked about at some point in the not even 24 hours I've been here yet, right? And these plug into different, that changes some of the dynamics. There's not really a good way to visually show it, but no longer is the generation coming from this dense interconnection and just finding its way down through largely a delivery system. Now you start to have injection points lower and closer to the load. That has some advantages. It has some disadvantages too for security, like there's more physical sites you have to do, but you've also distributed out where you're getting that benefit from, which has some good things in and of itself. So that's what I would say is a good mental model, that when people talk about the grid, don't think of just the line times however many there are. Think of the cloud, right? And then all getting to the endpoints down from it. And the reason I say this is because this has a lot of security implications when we talk about the consequences of it. For a particular facility, thinking about where it sits. Is it up in that dense interconnected cloud where you can knock out a lot of things and it's going to largely not have any impact on the load? Or is it somewhere on that serial connection, that last mile, or this series parallel path? If something happens there, the consequences are quite a bit different. And that's important to have in your mind as you're looking at what the consequences are for different risk scenarios so that you can allocate the proper resources to mitigation of those risks, looking at it from the business perspective. So the next mental model that I kind of want to talk about is how do we think about risk itself? And this is one where I still do get grouchy, unlike being okay with the word grid now. This just irritates me when people, as I call it, they use their risk words incorrectly. This is how we see it at INL and a number of the organizations that we deal with. You can have some quibbling differences about it, but threat is not risk, and it's not vulnerability. These are different concepts. And we're going to build out a little sentence here to help you remember it. So a threat. Threats are something that is an independent actor. It's an independent variable, and it's not something that you have direct control over. It exists outside your organization. In the cybersecurity world, threats are nation states, they're criminal gangs, they are occasionally the independent persona that does this for whatever motivation. But you can also think of threats like a hurricane, like a Idaho straight windstorm, like an earthquake, right? These are all things that are very much out of your control. But we're talking about cyber here, so I'm going to digress and use that for the rest of this. A threat, in order for you to really care about it, needs to have three things. It needs to have the ability to impact you, the ability to cause you harm. It needs to have the opportunity to do that, because you can't necessarily impose all kinds of harm at all time to all victims. There are certain things where the stars have to line up in a certain way to be able to have the situation where a certain scenario can play out. And then the last one is, because threats are sentient organizations, they're made of humans, they have to have the intent, right? If I have the ability to do something grievously bad to someone else, but I have no intent to, then I'm not a threat to them. And that's also important to this. This can change over time, and a lot of times we don't necessarily have perfect, or in many cases even good or any insight into what some of these are. A lot of it is best guesses. We call them assessments in the government, because it sounds better than guesses. So a threat exploits a vulnerability. And this is how they impose their harm. They exploit vulnerabilities. Usually it's not just one, it's several strung together in some combination. And when we say vulnerability, when we're talking to a crowd of cybersecurity folks, their mind jumps immediately to the National Vulnerability Database and the CVEs, and the CVE 2022, some number that correlates to a new software vulnerability that was just found, and it went in the database, and it was made public, and it was disclosed. Maybe there's a patch available for that software. Maybe there's some alternate mitigation. Maybe there's nothing, but it's out there. And as soon as that gets out there in the wild, the fact that there is a publicly available vulnerability, what we have seen time and time again is that adversaries, somebody out there that's capable and has the intent and has the opportunity, is pouncing on that. When it goes public, it's going to get hit by people, because that is that opportunity, because there's a window of time between when it's announced and made publicly aware and when people have largely remediated it, that smoke them if you got them. Let's go out there and see what we can exploit and see what we can get, and we'll figure out what to do with it later, perhaps. Solar winds, that may have been that way. Pick your recent large vulnerability, Log4j. That one was a technical vulnerability. But the important thing to remember here is that vulnerabilities don't just exist in software. They exist in humans. Everybody's heard about the phishing, don't click on links. Don't do it, it's bad. But there's also weaknesses in just humans as human fallible people. When we go into work every day, we have a sincere intent to do the right thing, but we might not always know what that is. We might make an honest error. We might not have the right resources. We might have to make a tough decision and get it wrong from a Monday morning quarterbacking perspective. And the processes that are used with the technology as an aid and the humans as the actors there, they have vulnerabilities also. I have not yet seen the perfect process that fits in all cases. I like to think of them as guidelines, things that here's what you should do. And the implication is you need to adapt those to your facts and circumstances. Those aren't always adequate. They're rarely adequate. And when you have a combination of a human with maybe without the experience or the education, the background training, with a process that's weak, that's a vulnerability right there. And when you put these together, philosophically, this is not an equation. That's why I didn't use plus and equal signs in there. I made it a sentence. But this is roughly likelihood. It doesn't work well when you try to quantify it mathematically, but when you take the threat piece and the vulnerability piece, this is sort of, okay, how exploitable am I? Exploitable is a good word, but I haven't quite figured out how to make that nice and smooth yet. And why? Because that threat wants to impose consequences. They want to bring some kind of harm to you. And we all have this innate understanding of what consequences means, bad things, things that are unwanted. And those mean different things in different organizations. The important point here is that there's two real big components to this, and that is the magnitude, absolutely how bad it is, and what's the duration, how long it lasts. Particularly in the electric sector, duration matters so much. Because if somebody is attacking, say, an energy management system and the SCADA controls, well, when I was an operator, those failed on their own on a fairly regular basis. You know, more months than not, it would fail on its own, and we would dispatch folks to the substations to monitor them manually and do what they could if they needed to, and we would get all hands on deck, all three people in this company, to figure out what was going on and get it fixed. And it would take us an hour or two, and that was a fairly regular occurrence. We knew what to deal with that. And it wasn't that consequential in the big scheme of things. But if it lasted a full day, that gets really painful. If it lasts 3 days and I don't have enough people to rotate through those different remote stations, I'm in a really bad spot here. So the duration, when you think about this, is very important. Please do remember duration when you go through and you're doing this exercise, consequence identification so you can do your risk prioritizations. And the right words are also important for what do we do with this. Threats are external. You don't directly have the ability to impact them. There's some legal issues. The US government might have some abilities that they can do, but that's a different discussion for a different venue. So what do? We understand threats, understand what they're capable of, what they might intend to do. As far as the vulnerabilities, two things. We can remediate them. When we find a problem, we need to fix it. When there's a CVE for equipment that we have, it needs to get patched at whatever priority. But the other thing that we can do is we can prevent them by proactive activities in design, in operation, in practice, in rehearsals that will help us make sure that certain vulnerabilities won't be able to be exploited. You might take some things off the table with engineering. And for consequences, similarly, you can reduce the ultimate consequences for many of these harms that we're talking about. You can do things that will let you be able to restore quicker. You can do things that will limit the ultimate magnitude of the harm. And these are all very specific to the use case that you're talking about. We have some examples from sort of the electric space that I can talk about offline as far as what it is, but this goes down a hole where you need specific discipline in that organization pretty quickly to start getting into examples that are meaningful. But you understand threats, you prevent and you remediate vulnerabilities, and you reduce consequences. That's the mental model. And the third mental model that I want to talk about here is sort of what do you do about it? And we came up with this graph as we were trying to understand how several of our different programs fit together. And we had this innate understanding, but we struggled to sort of explain it. So here's what we did. If you think about all the bad things that can happen, your entire risk space, I guess, you can plot it on some axis. And again, this is philosophy. This isn't math. You know, this is not algebra with the curves. But you can say it's this consequential and it happens this often. A lot of times people like to say likelihood, which raises the question, well, how do you know what the likelihood is? It's tough to do that, especially when you start looking at those high impact, very low frequency events that might not have ever happened. A meteor has never hit the Earth and wiped out human civilization, but it could happen. I mean, as far as we know. So frequency is a better way to think about it, and because it also opens the door for what we'll see in a little bit for the everyday harms, right? And you can plot everything you have, and it's going to form some curve that's convex to the origin like this. The shape of it will be whatever it is, but if it bows outwards, then that means you're going to be out of business or a smoking hole in the ground very soon because things that are very bad happen frequently. So with this kind of model of reality right there, there's different strategies we can apply to different parts of this curve. When you look at this vertical asymptote, very high consequence events, things that are catastrophic, they will kill an organization, they will bankrupt you, people could die. These are ones that you need to survive, a resilience strategy right here. And we just came up with kind of the term, risk reduction envelope. It's just words we made up, nothing there. But the idea there is make yourself be able to survive, reduce the consequences, back to that previous mental model. Now, if you look at the horizontal asymptote, this is why I like frequency, there's things that happen all the time. Your firewalls, your perimeter defenses facing the internet are constantly getting hit with different probes, different scanning attacks, things that in many cases, most cases, are probably being automatically mitigated. Hopefully that's the case. That's a good thing, right? But they're still happening all the time. And if something were to go wrong, something could change that would take it farther up that consequence curve. And when you look at these everyday harms, not only do you have to be able to survive them, but you have to be able to thrive. You have to be able to stay in business, make a profit, deliver your critical functions to society, and do it in a way where you're going to be able to continue operating. That's what you do on this horizontal asymptote right there. You can come up with some kind of theoretical line to say, okay, for risks below whatever that dashed green line is, we're going to accept those risks as we've mitigated them down with our automated protective devices, with our practice, with our procedures, our awareness training, whatever the case may be. And that leaves the most interesting one right here is this knee of the curve. And these are the sorts of events that are consequential enough to get the attention of your organization. Somebody in management is going to notice, they're going to have some questions. But they don't happen every day, so it's not a constant firefighting drill. They're frequent enough where you can start to see them and start to get some idea of what the trends are, what the similarities are from them, and you can learn from them. And when you learn from them, and then be able to actually implement some corrective action that will change the outcomes for this, that'll effectively let you change the shape of this curve. Make it be more convex to the origin, more of an L shape right there. Again, philosophical, not mathematical, but you won't have as much integrated area under the curve. That's less risk. That's a good thing. Each one of these three strategies has a part in your organization. And if you're only pursuing one of them, you're missing out on something. And that could be a significant consequence for your organization right there. Now, at INL and with some of our partners, we have a number of different programs that we do that look at different parts of this. And this is why we developed this curve right here, to be able to explain how all this portfolio fits together. At the very top, some of you may have heard about consequence-driven cyber-informed engineering. It's a program that looks at specifically engineering out as much of those catastrophic risks as we can. On that horizontal asymptote, we've got Ken Fowler here, who will be on the panel, that works for CyMani, the Cyber Manufacturing Institute. We use things that are manufactured every minute of every day in our organizations. It's important to get those right from a security perspective. Standards-based approach is here. Andre with ISA and the 62443 standards family. That's one of the really good ones that are out there. There's some other options, the NIST 800, 160 versions. But a standards-based approach that oftentimes deals with these things that you're going to face on a constant, ongoing basis. And then this one here, the one program that I'm actually the PI for, it's a whole other story for later on, but it's called Coyote, Cybersecurity for the Operational Technology Environment. And it's looking at those infrequent attempts where we actually have a cybersecurity incident that causes effects that we can see in operational technology space, something on the far side of that boundary. So looking at anomalies and what can we learn from them. That'll take us down a rabbit hole, so I'm not going to say any more about that right now, other than these are all things that you can that are accessible to you in one way or another from your company. And think about it this way. What are you doing for each one of these parts of this curve? And this is all wrapped in a bubble of what we call cyber-informed engineering. There's going to be a national strategy coming out later this summer. I don't know the exact date because it's constantly in flux, but we submitted a report to Congress. This is the one that Andre referred to with the security profiles that will detail this, and there's going to be a national cyber-informed strategy that is from the Department of Energy that goes into what does this mean? How do we actually start to do this and operationalize it? And in that, we have 12. There was 11, we added one. That's why I had to check my math right there. We have 12 different principles. And this is the philosophy behind it, where we've broken down 12 different sorts of activities that you can categorize things into that no matter which part of that curve for risk you're looking at, the catastrophic events, the things that happen every day, or the learning ones, you can look at these different principles. And what we're working at building out, we've got some of them now that are already out there. The consequence and impact evaluation is a great one. We've got some publications that are out there on there that you can go look at on the internet on your own. But we're looking to build out this body of knowledge for all of these and consolidate it in one place. Absolutely no intent that INL or the Department of Energy is the smartest folks in the room. We're not. That's why we go to lots of rooms with lots of other people from organizations with different perspectives too. But gather it up and make it something that's centrally accessible and create that body of knowledge for how we do cyber-informed engineering to be able to address risks for that whole spectrum of everything that your company is going to deal with. And with that, that's all I have, so I will hand it back to Larry.